Good evening. My name is Siddharth H. of Class 4D doing Mechanical Engineering in the Ramaya Institute of Technology. My USN is 1MS18ME169 and today I will be talking about transducers and recent advancement in transducers. Transducer is a device that converts energy from one form to another. Usually, transducer converts a signal in one form of energy to another. Transducers are often employed at boundaries where electrical signals are converted to other forms of physical quantities such as torque, energy, force, motion, etc. The process of converting one form of energy into another is known as transduction. Transducers are generally classified under the four categories: mechanical transducers, electrical transducers, active transducers, and passive transducers. These are the four different categories of transducers. A mechanical transducer is one which converts physical quantities into mechanical quantities, while an electrical transducer is one which converts physical quantities into electrical quantities, and they're known as electrical transducers. An active transducer is one which does not require energy from an external source to produce an output, while a passive transducer is one which requires external energy from an external source to produce the required output. Henceforth, I can conclude by saying that transducers play a significant role in everyone's day-to-day life. They can be present in every household and almost certainly in all automobile vehicles. A simple example, this is the conversion of mechanical energy into light energy. This uses a very simple transducer which converts mechanical energy into light energy. Well, that's the good thing about transducers. It can vary from a very small simple range to the highest most complex range. Transducers can be used in such small toys and household items all the way up to certain medical fields. The recent advancement in transducers mainly include digitalizing all the transducers. Previously, in the olden age, all the transducers used were mostly analog. But right now, in the modern world, most of the transducers we use are not analog but digital. This conversion from analog to digital is one of the major advancements in transducers over the past few years. Ultrasound technology and ultrasound imaging. Recent advances in ultrasound technology include spatial, contrast, and vascular resolution. Transducers play an important role in achieving these improvements. New advances include digital beamformers instead of the previous analog beamformers that work at their best when coupled with broadband technology. New multi-layer and multi-array scan heads improve the signal-to-noise ratio and increase the transmitted energy. New transducers and imaging algorithms allow real-time acquisition of large field of views and even their three-dimensional volumes. This requires the refinement of two-dimensional matrix array transducers, which will produce high-definition volumetric imaging. Ultrasound technology and ultrasound imaging is mainly used in the medical fields. Therefore, evolution in transducer technology permits to interrogate the vessels with higher Doppler frequencies. Let's talk about beamformers, which are an essential part in ultrasound imaging. A beamformer is a system of electronics that determines the shape of the beam. Earlier, beamformers were either analog electronics or a combination of analog and digital electronics. While in the modern transducers, the beamformer is totally digital, which enables the ultrasound beam to be focused with greater precision. However, there are a few disadvantages to having digital beamformers over analog beamformers. Some of the major disadvantages of having a digital beamformer are that the amount of data generated, the cost factor, the power consumption, and the losses. To be precise, the amount of data generated from a digital beamformer is comparatively greater to that of an analog beamformer. Therefore, the bandwidth used also increases, which is not desired. The power consumed by a digital beamformer is really high because the processors present in a digital beamformer require lots of power in order to function properly. Finally, the expenses. the overall implementation of a digital beamforming system is really expensive. As mentioned earlier, modern transducers use only digital beamformers, which enables the ultrasound beam to be focused with greater precision. While using an analog beamformer, it is not possible for us to produce delay timers with the accuracy required. However, the major advantage of using a digital beamformer comes here. In digital beamformers, we can produce the required time delays with pinpoint accuracy. 1.5D and 2D array transducers were used in digital beamforming. But the main disadvantages of using such array transducers were that the manufacturing of 1.5D and 2D array transducers is really difficult. But in the recent times, the technical challenges associated with manufacturing 1.5D and 2D arrays have been met. While a 1D array may have n active elements and n electrical connections and channels, usually a 1.5D array would have somewhere between 2 to 10 n electrical connections, and a 2D array would have n square connections. The manufacturing of 2D array transducers is technically more difficult and challenging than that of a 1.5D or a 1D array. 1.5D arrays have been available for several years, pioneered by General Electric. In the year 2002, Philips introduced a fully populated real-time 2D array through a unique approach involving micro beamformer ACEs in the transducer handle. Well, now let's have a look at 1D, 1.5D and 2D array transducers that are usually present in a digital beamformer. What you see here are the different types of multi-dimensional arrays. The one on the top left is a 1D simple array. On the top right is a 3-row 1.25 dimensional array. The bottom left is a 5-row 1.5D array. And the bottom right is a 6-row 1.75D array. For a one-dimensional array, the elevation, aperture and focal distances are fixed. This is a 1.5 dimensional array with 5 rows. The rectangular boxes you can see are the array elements. As there are only 5 rows of array elements, this is a 1.5D array with 5 rows. The number of rows of array elements can be varied according to our requirement. For a 1.5D array, dynamic focusing is achieved by adjusting the delay of returned echoes or transmitted pulses similarly to what can be done on an azimuth plane. The areas of all rows are typically made equal to ensure equal sensitivity and input electrical impedance. This is a two-dimensional array transducer. Only a full 2D array transducer can allow dynamic focusing and beam steering in azimuth and elevation directions. Three-dimensional imaging by a two-dimensional array may be accomplished in two ways: pyramidal scan and rectilinear scan. The picture on the left shows a 2D array performing pyramidal scan, and the picture on the right shows a 2D array performing a rectilinear scan. Rectilinear scan offers the advantage of reduced complexity and thus the cost, but suffers from an inferior resolution due to the smaller aperture size. Another potential 2D array technology is called CMUT, Capacitive Micro Machine Ultrasound Transducer. The transduction mechanism and overall active area are less efficient than those for a piezoelectrode transducer, but provide adequate sensitivity for imaging. This is a capacitive micro machine ultrasonic transducer, or in short, CMUT. It has great potential for making the fabrication of two-dimensional arrays. CMUTs are more cost-effective, solving the interconnection problem, and allow integration of transducers and electronics and miniaturization. The silicon nitride membrane and the silicon substrate form a capacitor that makes the membrane vibrate upon the application of an AC voltage, and the golden layer is an electrode. The sensitivity of the device is inversely proportional to the gap width. The sensitivity hence increases with a decrease in the gap width, and vice versa. The thickness of the membrane determines the resonance frequency of the device. Few of the major advantages of a CMUT is that the improved axial resolution is clearly seen due to the larger bandwidth of a CMUT. and it is no longer necessary to match the acoustic impedance between the transducer and the loading medium. CMUT technology, however, has a couple of shortcomings. There is a slight decrease in sensitivity and the need for a bias voltage of over 100 volts. Here are two images obtained from ultrasound imaging. One of them is from a CMUT and the other one is by using a conventional piezoelectric transducer array. The image on the left is obtained by using a CMUT array. As you can see, the image on the left is more clear and focused, while the image on the right is obtained by using a conventional piezoelectric transducer and is not as clear as the other image. Therefore, I would like to conclude by saying that the major scope for advancement in transducers is mainly in the fields of ultrasound imaging. Thank you.